got Wes Purvis, who's Senior Product Manager here at Juniper Mist, as well as Peter McKenzie, Director of MQ Training Services. And
it's great to be back on a webinar with you, Wes. I think last year we did a good series, didn't we, on sort of introducing Wi-Fi 6E as a technology. But what I'd love to get a bit more out of this session is some sort of, okay, now Wi-Fi 6E is out there, what are some more practical tips, I guess, on deploying it? And I thought to kick it off, it'd be good to have a discussion around SSID practice. So from my point of view, when I'm implementing Wi-Fi, and I've been doing it with 2.4 and 5 gig, I've become a real believer in having separate SSIDs on 2.4 and 5 gigahertz. And the reason for that is just because of the better performance we get in the 5 gigahertz band, with it being less congested and just higher performance, more channels, etc. So when you're doing things like, Zoom calls and team meetings and webinars and voice and video, you just get the performance you require out of 5 gigahertz. So making those corporate networks 5 gig only and leaving 2.4 for maybe guest or IoT tends to be the way I go now. But I guess my question is, where do we go with 6 gigahertz? Because from what I can tell, we've got two choices. We either yet put another separate SSID on 6 gigahertz, which we could do, but actually, does that give us as much of a benefit, or do we actually go for having the same SSID and seeing 6 gigahertz as almost an extension of the 5 gigahertz band, giving us sort of all the 5 gig and 6 gigahertz channels for our corporate SSIDs? What do you think?
Yeah, we have more options now.
We do.
And I don't think there's a right answer, or a one size fits all answer. Just like there's different strategies even with just 2 bands that people are used to. So what I've seen customers do, and I think what has worked pretty well is kind of what you have described. So you treat 6 gig as an extension, treat it similar to how you treat 5 gig. So it really kind of depends on what is the purpose of the SSID. So you may have like IoT, like an IoT SSID that is 2.4 only today. Maybe you make that 2, 4, and 5, and then you have your corporate stuff on 5 and 6. But I think one thing that's important is when you have 6 gig, you have 5 gig for fallback, just in case there's issue discovery or whatever it may be. I personally don't like 6 gig only SSIDs. If you have 6 gig only, you need to make sure you at least have 5 gig or 2.4 somewhere on that radio, so that the reduced neighbor reports can work and clients have a much better experience discovering 6 gig when the RNRs are available. I
think that's a good point, actually, is that 6 gig only is probably not the best option at the moment, not only because we don't have that many 6 gig devices available. There's going to be a lot of still 5 gigahertz devices out there, but you're right, for the discovery process we need to have at least one 5 gigahertz SSID on that radio. I think that's a good point.
Yes, so it kind of like, these are the options in a nutshell, right? You spin up a 6 gig only SSID, you have band specific SSIDs, you just modify your existing SSIDs to add 6 gig and WPA3, or you can turn on transition modes. So I think in general, what we're seeing is people are either just adding 6 gig to their existing SSIDs, and using like a transition mode, especially with that 1X, or they are or they are doing kind of this band specific thing based on use cases. So this IoT, you don't really need 6 gig for, so keep it as 2.4 with 2.4 and 5, or 2.4 with just WPA2 encryption, and then any of the devices that may take advantage of 6 gig, spin up like a 5+6 SSID for for those types of use cases.
Yeah, I think something else from my point of view, being a European, being someone set in the UK at the moment, where we've only got 500 megahertz effectively of 6 gigahertz spectrum, that's basically like giving me the 5 gig band again. So using it as a band on its own doesn't give me a huge benefit, but if I see it as an extension of the 5 gig band, then it effectively doubles my channels available to my corporate network. And then it does give me the extra capacity that I'm wanting as well. So to me, that would be another benefit of seeing, using the same SSID for 5 and 6 gigahertz.
Yep.
Okay.
Yeah,
sorry. I was just going to say, so I guess from my point of view, there's definite benefit there to having the same SSID on 5 gig and 6 gigahertz. However, it does bring up another question or potential problem in my mind, and that is WPA version 3, which is mandatory in 6 gigahertz, and yet many of my 5 gig clients don't support WPA version 3. So how do I configure my SSID if I'm going to do that?
The answer, as always, is it depends.
Great.
Actually, a couple of weeks ago, did a webinar deep dive on this topic with Jennifer Manella. If anybody is interested, to check that out. But in a nutshell, it comes back to it depends on your security type. So for 802.1x, WPA3 Enterprise is safe to enable. We've enabled it many customers now. There's very low risk of interoperability issues, especially if you use WPA3 Enterprise Transition Mode. And the reason WPA3 Enterprise Transition Mode, I'll have a next slide, but on it is WPA2 versus WPA3 Enterprise are very similar under the covers. So there's low risk to enable, and enabling transition mode is also something that's low risk on enterprise.
Management frame protection is about the only thing that changes, isn't it, between the two?
Correct. Yeah. And it turns out management frame protection has been supported. A lot of devices support it. Yeah. And by turning on transition, it gives an easy out if somebody doesn't support it. So then you think about your pre-shared key or passphrase SSIDs, your personal SSIDs. So WPA2 to WPA3 personal is different. So you go from a PSK, a pre-shared key based, to this SAE, simultaneous authentication of equals, where each device has unique encryption parameters, but not necessarily derived from the key. And so what we've seen here is there is potential interoperability, more likely to have interoperability issues with devices supporting either WPA3 only, or if you do WPA3 personal transition. Now we've done some pretty large events with WPA3 personal transition mode enabled, and we had this year. So last year we had 85% of devices connect WPA3. This year is 95% of devices. And then the remaining devices connect WPA2, and a small portion did not connect at all, right? So that's the risk, is devices that aren't connected. So it's possible for, one strategy you consider for a WPA3 personal SSID is you spin up a new SSID for WPA3 personal and leave your existing WPA2 personal SSID alone. Maybe do different VLAN so that you have the enhanced you have enhanced security. You take advantage of the enhanced security. But that's one possibility is you start a new SSID for WPA3 personal and move devices to it that are capable of supporting it.
Yeah, makes sense.
And then lastly is around guest access or open access and OWE. So OWE is I'll say the least mature. Apple, Mac OS and iOS just added support for OWE, like iOS 16 and latest Mac OS. So this is, and that's, in a lot of environments, Apple devices are, make up a significant portion, at least in the US, right? I think worldwide probably a little bit lower. But it's, so what we've seen with, Open and OWE is not as well vetted. We've turned on OWE transition in a few places. It seems to work reasonably okay, but you have the potential of devices that that could have it, that won't like the transition mode, and the OWE transition is kind of is ugly anyway. It needs a hidden SSID and whatever, but then you don't really have full device support, or you previously didn't have full device support of OWE. So it's not, OWE is the least clean, let's say. Right. And then I think just in general, even if you're not even if you're on a 6 gig journey, not on a 6 gig journey, you should be looking at WPA3. You can turn on WPA3 without having 6 gig APs, get comfortable with it in your environment. So that, if you ever need to move to WPA3 or you're looking to adopt 6 gig, you can just easily do it. You're not making 2 changes at once by, new APs and WPA3. Just do WPA3 now, in a safe area on your network. And we've seen customers do that as well. It's, it makes it pretty easy to migrate when you're ready to 6 gig. So just to show what is the difference between, WPA3 Enterprise and WPA3 Enterprise Transition, it sets, as you can see, management frame protection to optional, or capable, I should say, right? So it's not required, it's capable, which is optional. And then there's, it removes one of an AKM, so it's not actually a huge deal. So this is why we say WPA3 Enterprise specifically, WPA3 Enterprise Transition specifically is safe to turn on. And then just a note for those of you that use device management. So most of the MDMs out there don't very well support WPA3 Enterprise. So like you can't, in a lot of them, this is the iOS configurator, app configurator. You can actually configure WPA3 Enterprise, but in a lot of them you can't. But it turns out that's not a big deal. Just configure WPA2 Enterprise, and clients will happily connect at WPA3, because many of the devices even don't realize that they're connected to WPA3. Like it just basically, if they're connected with management frame, you're WPA3. That's the difference.
Yeah. Okay, so I guess this brings up a question to me, because you've talked a lot about transition mode, and in fact, actually, Mike Atkins has asked a question about transition mode, but transition mode isn't allowed in 6 gigahertz, is it?
No. So
how do we? So actually, if we've got an SSID in both bands, how surely, and we enable transition mode, does that then disable it in 6 gigahertz? How does that work?
So for MIST specifically, I don't believe this is true for all vendors, but MIST specifically, we've tried to minimize potential issues and kind of ease migration. So we allow you to configure WPA3 transition mode, either enterprise, personal, with 6 gig enabled on the SSID. And so what we do, under the covers is on 2, 4, and 5, we do transition. And then on 6, we do the pure WPA3 only. And okay. The reason that we do this is it's 2 reasons. One is, so like normally you would have to create a separate profile here, a separate WLAN. So you would do one for 2, 4, 5 and one for 6. 2, 4, 5, you do your transition. 6, you do non-transition. But the problem with that is you have 2 SSIDs. So if you use 11R won't work between the 2 WLANs. Yeah. Like that's true for any vendor. And then typically in the management platform, it'll show us two separate SSIDs, which isn't very clean. So this eliminates both of those, and sort of it allows you to do edge your own, basically.
Yeah, it's a really smart solution actually to this problem, I think. because it allows, you end up with catering then for all clients, don't you? So if you are a, if you're a 6 gig client, you will be able to support WPA3.
Yes.
And so therefore, you'll be able to be backwards compatible in 5 and 2.4 and use that. But if you're a 2, 4, 5 gig client that doesn't support WPA version 3, well, you can still work in those 2 bands. So it gives you the best of both worlds, really. So I think that's a really smart move by Mist. I like it.
Great. We spent some time on that.
Yeah, no, it's really nice. Really good solution. Okay.
Peter, there's a couple questions I see that have come up.
Yeah.
So maybe let's take those. Let's see. So
Yeah,
WPA3 only without transition mode seems like it's going to be problematic for guests and users as they travel to other facilities. Doesn't it seem like you'll have to support transition mode if you want Edge Roam to work and get users on 6K reliably? I don't know. I mean, so for .1x, .1x specifically, users roam pretty well between WPA2, WPA3. We haven't seen any roaming issues. Now on personal, yes, you have roaming issues between WPA2 and WPA3, but enterprise, not really. So you could technically do WPA3 only without transition mode, and users will be able to roam to it if they support WPA3 only. And then in other areas, they'll happily go back to WPA2.
I think just from a pure compatibility point of view at the moment, though, the sensible thing is to enable transition mode, isn't it?
Yeah, I do. Yeah,
especially the way it's implemented in Juniper Mist, I think.
Yep.
Yeah.
This is WPA3 Enterprise specifically, right?
Yeah.
You don't necessarily have that same recommendation for personal, but for enterprise, yeah, transition makes sense. Let's see, question from Anish around management frames will only be encrypted after the key creation.
Yeah, that's correct.
Yep. So
with protected management frames, it will only actually encrypt a certain set of frames. All frames get protected with a message integrity check, but only certain frames which are sent after the association are actually encrypted. So you've got a set of action frames which get encrypted, and you've got basically disassociation and deauthentication frames which get encrypted. But obviously, beacon frames, association frames, authentication frames, they don't get encrypted because they're all needed prior to the association and ultimately the 4-way handshake. So you're looking at frames after the 4-way handshake, which are going to be encrypted.
And then there's one last question from Andy around MPSK. On last slide, I said MPSK limited. So in the webinar with JJ, I go into some the challenges of MPSK and WPA3. The kind of the Cliff Notes version is there's two ways to do kind of MPSK. You do this like MAC address based or MAC less. So the MAC address based, where you basically map a key to a MAC address is trivial, is easy to support. Mist does not yet support that mode, but we will, and other vendors support it today, where you can use this MAC based. MAC less, which is where we want people to go, and what we support today in WPA2 is very challenging in WPA3, in the WPA3 world, and so we're looking at what can be done there, but that's the challenge, because you're not deriving your key from the passphrase, and so that's what presents the challenge.
Yeah, great. Okay, let's maybe talk about something else, and because you've said we've sort of talked about having the same SSID on both bands. We can see how transition mode helps the security with that. But I guess if you were doing that, what about how clients select the BSS to connect to? Because we've now got 5 gigahertz, we've got 6 gigahertz. We may have different channel widths on different bands. And what sort of, have you got any experience of what do clients prefer?
Yeah.
To connect to?
Yeah, this is interesting. Okay, so let's take a step back. So we performed some testing, and like, you know, I have a 6 gig AP in my house. I think you probably do too. You know, a lot of people do, and I think people are having 6 gig discovery issues, like with a single AP, and you know, sometimes clients prefer, sometimes they don't prefer. But I don't actually think that's a really good measure of determining 6 gig preference. You need to actually test in like a, you know, in a real environment. So this is a floor of one of the Juniper buildings in Sunnyvale headquarters, and so there's 26 APs on this floor, 26 AP45s. We basically put a bunch of client devices, different client device types, onto a cart. You know, have them pinging and doing various things, and then just walked around to see what's the roaming behavior like. How do they roam? How do they, you know, do they prefer 5 gig, 6 gig, you know, whatever. So just from like RRM perspective, RRM ended up, you know, putting transfer power pretty similar between 5 and 6 gig, a couple dB higher in 6 gig. So the size of the circle here is the kind of the relative transfer power. But anyway, so we'll go into some I have some graphs, and then Peter, I will answer your question.
Okay, good.
So I showed this graph at WLPC, and I think you know,
Yeah, I seem to remember it. Lots of nice, pretty dots. Yeah.
But it was on a, you know, projection screen, and I like, this graph is not very intuitive, but it's to say the different colors are different client devices.
Okay.
So I have like 2 MacBooks in here, an iPad. I have 2 Android phones, one Windows laptop with a Qualcomm chip in it, another Windows laptop with an Intel chip in it. So like a mix of client devices, and each one of them is represented here based on a, you know, a color.
Yeah.
The reds are the MacBooks, the blues, you know, light blue, dark blue, I think are the Intel, and oh, I got my thing covered here. Blue, sorry, the blue is the MacBooks.
Blue are the Macs and red is Windows. Yeah, that's right. Yeah.
So the point here is all these clients are on the same, they're on that same cart.
Yep.
But this is captured from the AP. So this is how the AP or APs are hearing those client devices. So
you can see a great variation in signal strength, can you?
Like at the same time, some clients are heard at neg 50, neg 55. Some clients are heard at like neg 75, neg 80. So and the point here is not all the devices are on the same AP. So even those that are on the same AP may be heard differently, but they may be on different APs. And then, you know, as you walk around, signal strength goes down, and then clients roam, but they don't all roam at the same time. So you can kind of see, like, if I put it in line graph format. So here is those clients, and the blue, right? Those are the MacBooks. Right, those are MacBooks on this one. Yeah, MacBooks. So there are 2 MacBooks on the same cart. They roamed about 30 seconds after each other.
Yeah, you can see that. Yeah.
So you know, you get you get varying behavior. That's the point. But they all do, you know, tend to roam, and you know, so anyway,
they all roamed somewhere within a period of time of each other, didn't they? But they roam at different times, which is quite interesting. Yeah.
Right. So then let's talk about your actual question, which is 5 gig and 6 gig preference.
Yeah.
It turns out channel bandwidth matters. So first, I ran out of 6 gig spectrum in my house. I configured all 160 meg channels. So, you know, we need more spectrum.
Yeah, you need more spectrum in your house, definitely.
I have, you know, there's some channels at the, you know, the upper end here that don't fall into a neat 160. So I guess I do have a couple channels, but you know, I want more. Well, you're probably, you know, the point
but that's a good point, isn't it, for how, you know, in an enterprise, 160 meg channels we're going to run out of quickly, even on even in the 6 gigahertz band. It's a nice illustration of that.
Yep. And yeah, so you're like channel bandwidth, we have all the spectrum in 6 gig. In the US, we have 1200 meg. you're up 500 meg. So, but like, I think there's a perception of, oh, I have so much spectrum, I have unlimited spectrum. Not exactly. Like, you're going to run out if you do stupid things. So
yeah.
like configuring 160s in a dense environment, probably not the smartest thing. So that and the reason that the channel bandwidth ends up mattering is, so when a client roams, it looks at its candidates. Okay, I have a bunch of candidate APs that have acceptable signal strength. Which one do I pick? So they try to do a tiebreaker, and they do this like throughput estimation. And one of the ways that you can boost your throughput is by having wider channel bandwidth. So spatial streams and channel utilization is all things that look at, but the channel bandwidth is really important. So if you have 80s versus 80s and 6 gig versus 40s and 5 gig, there is a difference. So we did testing with both, where we have 80 meg configured on 6 gig and 40 meg configured on 6 gig. And so here's just one of those devices. I think this was actually a MacBook, but so 5 gig, 40 meg, 6 gig, 80 meg. And this would be true also if you do like 20 and 40. Like we saw if you just have wider channel bandwidth, clients will prefer 6 gig, right? They'll naturally stay on 6 gig. Whereas if you have similar channel bandwidth between 5 and 6 gig, you're more likely to see flopping between 5 and 6 gig. So Peter, like, this is to your point of, if you view 6 gig as an extension of 5 gig, maybe you do want similar channel bandwidth so that you have, equal preference between 5 and 6 gig. But
yeah, I guess in a very high density environment, like when we're talking stadiums and conference centers, where you're going to want to have the extra channels.
Yep.
Having your 5, if you want to get your clients split between your 5 and 6 gig radios, you probably do want to have the same channel bandwidth in those environments.
Right. And but then the flip side is, okay, for now, we don't have a lot of 6 gig clients, right? So like in real world, we're seeing, single digit 6 gig adoption, single digit percentage 6 gig adoption. So maybe you want all of your 6 gig devices to connect on 6 gig, and therefore you use the wider channel bandwidth to encourage devices to go to 6 gig.
That's a good point. And I think, so it's going to depend on what you want to achieve in your environment, isn't it?
Yep, exactly. And we saw this with most of the devices. They, like, if you have similar channel bandwidth, you're more likely to see some flopping between 5 and 6 gig. So it also comes back to, do you what is it that you're trying to do? And it's another reason why you may want to have a 5 gig fallback option, right? So you have 5 gig enabled on your 6 gig SSID, right? Like kind of view them as one entity.
But okay, but here's a question then. Because let's say I have 40 megs on my 6 gig and my 5 gig band, because I don't want, that preference on the 6 gig band. I'm thinking high density environments. What about the preferred scanning channels? Because we've heard a lot, haven't we, about actually these preferred scanning channels are the best way to discover 6 gigahertz APs. And I've even seen a lot of vendor recommendations saying that, 80s are the new 20s, and you should stick to 80s and set your primary channel to the preferred scanning channel, because that's the only way to guarantee your clients are going to discover all of my APs. But if I'm going to go for 40s, I can't stick to primary preferred scanning channels.
Yeah,
is that going to give me a problem? Right.
Yeah, unless you just say, I'm going to skip some channels. Like, I'm not going to use all my channels.
Unless I don't use all the spectrum. But then again, that seems a waste.
Yes. So you're right. So if you look on our documentation, we have a 6 gig doc and we say use PSCs. I think if you look at any other vendor, they still say use PSCs. So we were very curious of the question. So we did testing with every PSC disabled.
Oh wow, okay.
So in Mist, if you just, if you select automatic channels, we're going to use PSCs only. If you want to use non-PSCs, then you can go into manual channels and choose, enable the channels that you want. So here we disabled.
So here you've actually turned them all off.
Yep. And you can see all the primary channels here. None of them are on a PSC.
Yeah.
So this is those same 26 APs. It's the same setup. And so what we saw is clients did pretty well on 6 gig. So the PSC didn't actually matter. It seemingly matter. And this worked, for across all the devices that we tested. This one is one of the Windows. I think this is the Qualcomm Windows, maybe the Intel. But anyway, like this is good news for your neck of the world.
It really is, yeah, because I don't, given the amount of spectrum I have, I don't really want to use 80 meg channels. I prefer to use 20s and 40s.
Right.
So that's great news. But I guess, and so if PSCs don't matter, how are we discovering the 6 gig?
Well, and so that was the question, right? It's like the reason we were recommending PSCs, and I think the reason why others are recommending PSCs is because people were unsure of how devices would discover 6 gig. And so we just recently got Apple devices support, that support 6 gig in the wild. We had Windows, we had Android, but we now have the complete ecosystem. So we now pretty well understand how client devices discover 6 gig, and yes, they actually do discover, the non-PSCs. So the 6 gig discovery, right? There's a number of discovery mechanisms. Not everything is really used. The most important thing is this out of band reduced neighbor report. Right. So this is the 2.4 or 5 gig beacon or probe response, including information about the 6 gig SSIDs. So
that's right. It's an extra information element, isn't it, in the beacon frame, which lists all the 6 gigahertz SSIDs.
Yep. So in Mist world, I guess actually in general, so that R&R can include it can include co-located or non-co-located APs, meaning like the 6 gig AP, 6 gig radio on the same AP, or it could be a 6 gig radio on another AP. Now, I think most vendors and Mist specifically, we haven't. We're only doing co-located R&R today, and which I think largely makes the most sense. We actually wrote code to do the neighbor R&R, but we haven't actually. We're not actually using that yet. But
and that goes back to your point earlier that it's important to have if you've got a 6 gig only SSID, you want to have that 5 gig radio enabled so it can advertise its R&R.
Yep, exactly. Then there's other things in here like the MB-SSID. Like MB-SSID is optional. We've actually seen some interoperability issues with MB-SSID. We have it disabled. I think others have it enabled, but I don't think it really helps with its discovery.
It doesn't help with discovery from what I can tell, because it only advertises other SSIDs on the same radio.
Right.
So you're not going to, on a 5 gig SSID, you'll discover other 5 gig SSIDs, but not the 6 gig radios.
Right.
Yeah.
Then you have kind of the passive stuff, which is, clients can listen for beacons. There's this Phil's discovery or unsolicited probe, similar mechanisms. Both of these, in my opinion, are meant for 6 gig only SSIDs, although clients don't even look at 6 gig if they don't have an R&R. So I don't find a lot of value in the Phil's.
My big worry with both of those methods is just airtime consumption.
Yep.
Because we've fought a long time fought management overhead and like beacon overhead, and we've got higher data rates now, but that we generally turn up the lower data rates, which helps. But if you add in, consigned beacons or unsolicited probes, you add in a lot more management overhead to your channel. To me, they don't feel like the right solution.
Yeah, agreed. So we actually, MISC does not actually support fills, and I don't really see a reason to, at least at this time, right? Because these things go out every 20 milliseconds.
That's correct, yeah.
Which is frequent.
Which is a lot faster than your beacons.
Yeah.
Yeah.
Okay, and then clients can probe. So here's kind of what, just to kind of show. So with and without RNR. So without RNR, clients take a lot longer to discover 6 gig. Some will actually discover a 6 gig SSID, but some don't, right? Some actually need that RNR to discover.
And we're looking at the initial connection here, are we, in these videos?
Yeah. This is from off, right? This is from a fresh state.
Yeah.
So like from connected to ping, and this was, I did this testing last year, so I think things have actually improved a bit, but this was less than 5 seconds from connection to ping. And then with the RNR, it took, without RNR, it took, 20 to 30 seconds. And if it discovered it,
it's a long time.
Yeah. So RNR, really important. If you learn anything. And then, so do clients probe in 6 gig? The answer is yes. Clients probe. They will probe on non-PSCs as well. They can do a broadcast probe, but what they cannot do is a null probe.
Right. So that's really important then. So they do probe on the non-PSC channels.
They do.
I think that's important I think I've seen lots of questions about that. So, but they can do the wildcard null probe. So this is for an SSID that they've already discovered they're probing for.
Yeah.
So they've discovered it using, an hour information element.
Correct.
Or I guess 802.11k as well. I take it that comes into play.
Yeah. And so just on the probe, often you'll see it's the short SSID that's used, and not like the short SSID is like a hash of the SSID name. So often that is what's used in the probe, and at least that's what I've noticed in 6 gig.
Yeah, and that's quite a new thing, isn't it? That we're seeing that short SSID being used.
Just from a roaming perspective, clients will, so they'll use that probe. So they use what they learn in the RNR or 11K, and then they'll probe. So in this case, the client previously probed on client 21, on channel 21, and then it probed on 133, 197, but then it ultimately connected back on on channel 21. So clients probe, but they basically use it as like, okay, I know about these APs, let me get like a fresh data set. So it goes to specific channels generally that it's already learned about.
So it's learned that the radios are there, and it's just checking it can actually see it from its location, isn't it? And
exactly.
Yeah.
Yep. Here is 11K that you were asking about. So there is absolutely 11K. And one question that's come up before is, okay, in the 11K message, how do you, your channel numbers could be the same. Your channel number in the radio measurement. So how do you know, how does the client know which channel? Well, it looks at the operating class. This is defined in the spec of what band this means. So this is 6 gig. But yeah, 11K is absolutely used.
And it tells you effectively, the operating class tells you the frequency band.
Yes. Yep.
That's great.
Okay, and then Peter, there's one more thing.
Yes. Now this is something that's really interesting, and a good thing to finish, I think, the webinar off. I saw you tweet this out. You said that you had a 6 gig AP that was beaconing on its non-primary channel, and that just seems really odd. Is that have you got a bug with your AP? What's going on with? No?
So in this case, my AP was configured for 80 megahertz channel and 6 gig on channel 117. So primary channel 117.
So, and that's the channel we'd expect it to beacon on, isn't it? APs normally beacon on their primary 20 meg channel.
Yep.
That's typical. Normally at a or G data rate, or your minimum basic data rate. That's what I would expect.
Exactly. So this is actually, and here's how it looks in Wi-Fi Explorer, right? So it sees it on channel 117.
It does, yeah.
But then if I take a PCAP, I see my beacon. Look at these BSSIDs, EC04, EC05, on channel 125, which is one of the bonded channels in this 80 meg channel.
It is. That's crazy. So why would it do that?
So in 6 gig, there is an allowance for something called a duplicate beacon. So this
this was first, the concept, wasn't it? It was first actually introduced 82.11n, but nobody really implemented it. The non-HT duplicate format, I seem to remember, which was part of space-time block coding that no one really implemented. I remember the format, yeah. Yep.
So this is another reason. So okay, so in the example here, I captured on a different channel here. This is I've captured on channel 77.
Yeah.
Primary channel is actually channel 69 if you look in the 6 gig operation, but duplicate beacon is set to true. So, and you can see channel width 80. Regulatory info 0 means low power indoor. So the reason for this is, we feel, clients tend to scan the PSCs when they know about 6 gig. So it's just, if a client for whatever reason scans any channel, it's going to discover beacons. That's the whole point of it.
Yes. So you can scan. So if you've got a 80 meg channel, you could scan any of the 20 meg channels within the 80, and you would discover, and you'd hear the beacon.
Yep.
So actually, that's going to make it a lot. You can potentially scan faster because there's going to be a beacon on one of those 420s.
Yep.
So it makes a lot of sense actually, and it's nice to see that non-HT duplicate frame format being used actually.
This actually
where just I guess for people who don't realize, it sends that frame format basically allows you to transmit on each of your 20s. So if you've got an 80, that would be all 4 at the same time, as if they were sending basically a beacon out on each 20 at the same time. That's right, isn't it?
Yep.
This
threw me for a loop the first time I saw it. I was like, is there something wrong with my capture? Like,
yeah,
I had to look it up. But it's pretty cool to see actually.
Yeah, it's good to see it happening. That's great.
Okay.
Great.
So that's kind of where we, what we had for scheduled content. There's a bunch of questions that we'll answer. But I think to just kind of wrap things up, in the 6 gig world, we're definitely still learning. And I say that every webinar, every presentation, we're still learning.
Absolutely, we are.
And so things that we say today, can and will change in the future, and as we learn more. But if you're thinking about a 6 gig journey, even if you're not thinking about a 6 gig journey, you probably should start getting yourself familiar with WPA3. WPA3 Enterprise specifically is very easy to adopt. We find clients are actually attaching well to 6 gig. I think outside of the single AP home tests, where the R&R turns out to be important. Channel bandwidth plays into band preference, and PSCs, while not mandatory, are probably useful. But in Europe and UK, in other areas where you have 500 meg of spectrum, you could realistically use 40 megahertz channels and non-PSCs as well.
Yeah, it's great news that.
So then, just to leave with a couple resources, here's some things that are out there. Peter has a couple posts on mist.com/design updated for 6 gigahertz. We've put out a practical considerations for deploying 6 gig on our documentation site. So that it's basically a dump of everything we talked about in here. And then for those of you worldwide, there's a Wi-Fi Alliance link resource, which does a good job of cataloging which countries have enabled 6 gig. When they enable it, it usually includes a link to the regulatory brief. So
Great.
With that, I think let's maybe take some of these questions, Peter.
Yeah, let's do that.
Okay, so what is the allowed transmit power difference between APs and clients regarding the 6 gig? So Mike, this depends on the device classification. So today, everybody can use low power indoor. So low power indoor is if you're doing 6 gig, that's what you're doing today. And so clients, APs, and it depends on your regulatory domain, your country.
I was going to say it depends on that as well. Yeah.
Yeah. So like in the US, you can do like APs can do I think 5 dBm per megahertz PSD, and clients can do -1. So you have like a 6 dB difference there. Again, it varies on the channel bandwidth. That's another reason why you may want to use wider channels, because you can do higher transmit power because of PSD reasons.
It's worth saying on this as well, I think, is a lot of people get hung up, I think, on the power differences, but we're talking max allowed power here, aren't we? And actually, if you look at AP deployments, we very often don't run our APs at max power. So actually, you know, it's if you're not running your APs on max power, it might well be that the difference between isn't as big.
Right. Yeah, because you're not at maximum power.
Yeah, because very often you're not at max power either. So and that's something to bear in mind with we've got more power at wider channels, but only if our APs are configured to support that higher power. So if you've got your APs on a lower power, yeah, it's going to be the same across all channel widths as well. Yep. I've seen a lot of confusion around that. But actually, if you've got your AP configured at, you know, much lower power, you'll have the same. It can go above whatever you've configured the max transmit power to. So just because you double your bandwidth, it's not going to increase. It's just you've got the ability to be at higher power.
Yeah. Okay. James asks, did you find the devices inappropriately roamed back and forth between 5 and 6 gig? Or when devices met their expected roam trigger thresholds? So James, in the testing, in the testing I showed in here, generally the clients were in motion. We stopped at the beginning and the end of each run, but generally we're walking around. And so in that case, no, we didn't see band hopping. Also, when the clients were stationary, didn't see band hopping. Usually I don't often see band hopping between 5 and 6 gig, because what I found is many devices will, in addition to the channel width, they may actually put higher weightage to 6 gig in general, right? So they may just prefer 6 gig. Like that's true for Intel. They put a higher weightage to 6 gig regardless of bandwidth. I don't usually see huge amounts of band flopping. Now, in other environments where take the classic case of a dorm, right, where you deploy, where you would often see this, when you have a hallway deployment, clients in a room at the roam threshold, you would see roaming, flopping between 2, 4, and 5. Could you see it between 5 and 6 in that case? Probably, but in the scenarios that I've tested, no, I haven't really seen it.
Yeah, I think in the same scenarios, you're going to see, AP flipping in 5 gig, just because it's not a very well, good design. You're going to see that, but most clients still have a roaming threshold, which they're going to trigger a roam on. And if you're above that roaming threshold, it's going to be fairly consistently staying to that AP, regardless of the band. Yeah. Great.
Let's see then.
What else we have?
Band steering in tri-band 2456 radio AP. How does the band steering work?
You can answer it from a Juniper Mist perspective, I guess.
In Mist world, we do have a band steering option, but in general are a little bit laxed around steering to 6 gig because we don't, yes, clients are probing, but they don't necessarily probe. I think they generally don't probe as much. So we don't necessarily know if a 6 gig client, so at least in Mist world, we would typically recommend do not enable band steering. Even if in a 245 world, don't enable band steering. Like use let clients make a choice, use RF. So have higher transfer power in 5-6 gig versus 2.4, and you'll see your clients naturally prefer 5 and 6 gig.
Great.
Okay, anything to add, Peter? Or should we just move on?
No, I think that's good. I think that answers it.
Let's see, will fills have a continuous support? I guess, is that asking, does the AP always have its fills announcement? If that's the question, the answer is yes. Every 20 milliseconds for as long as fills is enabled, that AP will send out a message.
Yeah, when it's supported, yeah. Which is, but as you said, we don't. That's not supported with Juniper Mist, is it?
No. And I think that most of the vendors that support it are only supporting it when you have a 6 gig only SSID.
Yeah, it seems to be, from my experience anyway, a lot of more the sort of SOHO vendors that seem to support it.
Yep. Yeah, I mean, I think there's like a manufacturer out there who doesn't support R&R, but they support fills, which makes no sense.
Yes, I agree.
Okay, do stations do duplicate RTS CTS on 6 gig like they do on 245? Yes, they do.
An easy one.
Let's see, Nick asked, for existing Mist customers, will there be any tools available in the dashboard to help guide them to a 6 gig deployment based on existing SSIDs and client capabilities? That's a good one. So we don't have anything planned. We have our our document that walks through some migration strategies, but actually building something into the dashboard, it's really just as simple. Like we enforce some, we give you some guidance. So when you click, so if you have an existing SSID and you go to enable 6 gig, we make sure we do a check that WPA3 is enabled. So if you don't have that, then you can't enable 6 gig. So that kind of stuff is there, but actually like making recommendations for you, I think would be tough because it's so much like environmentally dependent.
Right.
Okay. And then Andrew's, I heard fills is not currently allowed in the EU. No, that would be false. There would be no restriction on that. Yeah, I would be curious where you heard that, because that wouldn't make a lot of sense.
No, I've not heard that either.
Because it's a protocol thing. It's not a regulatory thing.
It's not a regulatory thing, yeah.
And then related to band hopping between 5 and 6 gig, what about near the edge of your deployment of 6 gig as you walk from 6 gig available? Okay, so if you've only upgraded particular areas of your deployment with 6 gig APs, and then you walk into a 5 gig area, what happens? I think that's the question. So the answer there is it depends on the security type. So if you have consistent SSIDs where you have WPA3 or transition enabled, you're not going to notice a difference. Clients will just go to 5 gig, no problem. But if you have separate SSIDs, meaning like, a 5 gig on your older infrastructure, you only have WPA2, and then on your newer infrastructure, you have WPA3 or transition, and it depends on the security type. So if it's enterprise, clients roam pretty well for enterprise. So no issues roaming between WPA2, WPA3 enterprise. But if it's a pre-shared key, WPA2 and then WPA3 personal, SAE, clients don't roam very well there. So in that situation, you would want to at least have transition or WPA3 only, so that you could have a good roaming experience, and clients wouldn't have to fall back to WPA2, which they don't do gracefully for personal.
I think that would be why it's such a good idea to have transition. on those on your 2.45 gig, so that if you were on 6 gigahertz, you know, then you've got you can also use WPA3 when you roam out of 6 gigahertz coverage area.
Okay, that's all the questions that we have. I don't think I'm missing any.
No,
So,
I think we got through them all.
Yeah, with that, if anybody has a question, now is your time to ask it. If not, thank you everyone for joining.
Yeah, thank you for joining.